Welcome to another Fenestration Canada podcast.
This is Tech Talks, live conversations about the regulatory environment with Al Yagalis.
So, hi everyone, here is Stefan, your Executive Director. Today we have a new Tech Talk episode, so I'll let you start.
Thanks. So today we're going to talk about the changing value proposition for windows from the point of view of builders. And our guest today is Andy Oding. Andy is a Vice President of Building Knowledge in Ontario. And I've taken part in a couple of their webinars and was very impressed with their knowledge of building science and the way they apply it in Part 9 buildings, residential buildings. I guess even you guys are involved in MERBs as well, aren't you, Andy?
Yeah, that's right. 3 stories and down. Yeah.
3 stories and down. So yeah. So very interesting background. And our guest, our main guest, I guess I could say, is Andy Oding. But also joining me on our call today is Terry Adamson. Terry Adamson is the Technical Director at West Tech Windows in BC. And I thought Terry would be an interesting guest to have on the show because, I think the topic we're going to discuss today, there's kind of echoes between what Andy and their group at Building Knowledge have discovered with respect to the performance path of the code and what energy modeling does to actually demonstrate the contribution that windows make to the overall energy performance of a home. And that's the same kind of emphasis we find also in the BC STEP code. So this session isn't about STEP code, but I think Terry, having experience in supplying windows to the STEP code market in BC, would also be able to contribute to this discussion and of course take part in answering questions from our callers. So Andy, maybe you could introduce yourself to us. Tell us how you came to be at Building Knowledge, and just so we get to know a little more about you for our Fenestration Canada members.
Yeah, no, thanks, Al. Thanks, Terry. Yeah, so we, Building Knowledge Canada is a building science company for Part 9 housing. And we work with builders primarily in Canada. And then we have a sister company, Construction Instruction, that works in the US with builders there. My background was as a builder. I mean, I grew up building homes in the fine state of Michigan, south of the border, and framing houses, worked my way through high school and into college, and then ended up building homes in Asheville, North Carolina. And you'll wonder, why are you in Canada? And that's all I have to say is my wife was from Hamilton. Now you know. When I did come to Canada, I started working in the late 90s for a builder called Reed's Heritage Homes. And at that time, they were one of the largest production builders in Canada. And at our top, I was there 12 years, worked in the field, service, construction supervisor, became quality control manager, then was product development, ended up being director of operations. And during the early 2000s, we built the first LEED home in Canada. Yay-hoo. Yeah, first LEED platinum home. We only spent $170,000 in extras to get there, but hey. We built all Energy Star homes. We were up around 1,000 homes a year at our height, attached, detached. And anyways, I ended up going back to University of Toronto, their building science program. And as a builder, I always saw stuff happen and everybody could tell me what to do and how to do things, but very few people could tell me why things happened that we saw in the field. And, I started to get introduced to people like, John Straub and Dr. Joe Steebrook, and started reading the old IRC Building Science for a Cold Climate and the Building Science Digest. And I couldn't get enough of it. So went back to school, ended up in 2012 by good fortune to get invited to come to Building Knowledge Canada. Been here 9 years. So I'm one of the partners here with Gord Cook and a few others, and we're just having fun. There's staff about 24, and we work with builders and developers. We work a little bit with other partners as well too, government and so on. But our goal is just to bring the building science to the forefront. Now, others would know us as the people with the big red door, right? Yeah, so we have a field team that does blower door testing and Energy Star and LEED. But a lot of our work these days is just about complying with codes in Canada.
That's very interesting. I understand your sense that you wanted to know why are we doing the things we're doing in construction, right? And especially when codes change and the paradigms change, and now stuff that you thought was perfectly good all your life is changed, and they want you to do something different, and it doesn't make sense sometimes. And it gets worse when the consultants themselves, tell you from job to job to do different things.
Yeah, that's right.
and you want to really understand what's going on here. What are they thinking? So definitely, a very interesting background and a very interesting perspective that you bring to this discussion today. Terry, maybe just give us a little bit about yourself, or
sure. Yeah,
I know you.
Yeah, for sure. I'm with Westech Windows and Doors in Chilliwack, just outside of Vancouver in Southwest BC. Been with them for a very long time. I'm the technical director there. I want to make sure I don't take away from what we're going to talk about, but Westech, has looked at what was coming 10, 15 years ago. There was already talk about things like performance-based projects and step codes and higher performance requirements for products. And they really embraced it, even though at the time, a lot of people were going, well, you're not going to be able to sell this. Nobody's going to buy this product from you. It's years away before we're going to have to worry about any of this. And that was all good. We embraced it anyway. Our management was very proactive thinking about this. And, over the last 10 years, we've developed a lot of high performance products, done a lot of R&D work and created new systems that are very high performing products, very high performing, some passive house and others that are not passive house, but are very close. And surprisingly enough, these products do sell. And we've sort of gone against the grain of how some manufacturers think that, a more expensive window is not going to sell to the majority of people out there, or even a minority at that point. But you know what? That's changing, and I think that's where we're headed in this conversation. And I'm going to be able to share what we're seeing in British Columbia for a market for very high performing and which translates oftentimes to expensive windows. So,
and I think the interesting point here is that the customers for these windows are builders, aren't they?
Yes, absolutely. And
the demand is coming from builders.
Yeah, and that's being driven, not only by things like the step code and regulations that we're faced with, but actually homeowners are driving it too. Homeowners are seeing what's going on. They understand that, the climate's changing. We're faced with all kinds of challenges in that respect. And people, have a conscience and they want to do better and they want to be comfortable in a better home. So true, the builders and the regulations are driving it. But we're seeing more and more that homeowners as well, and people that are building their homes are also looking for, quote unquote, better products.
Thanks, Terry.
Sure.
So what really, when I discovered Andy, but also Gord Cook, who's also with Building Knowledge, was a webinar they put on called Cracking the Code, and it had to do with the SB 12. Compliance energy requirements in Ontario. And I thought it was, often we think of BC as the place where, people have crazy high performance expectations for homes and code requirements that won't be in effect anywhere else in the country but BC. But I was really surprised at what I heard from the Cracking the Code webinar. And really, the focus of that webinar was showing builders how they could comply under SB 12 more profitably. That was one of the takeaways I took, Andy. And maybe for the sake of our listeners outside Ontario, the SB 12 performance level how does that rank between the base code level of the NBC? Is it really the same thing, just with different words and different compliance paths, or is it more stringent? Tell us a bit about that.
Yeah, so the SB 12 first came into effect in Ontario in 2012. And it was Ontario's attempt at a minimum energy efficiency standard for an entire new home versus just bits and pieces. So how it would compare? Yeah, it's more or less the 936 of Ontario. So, what you have in 936, which is the base of the NBC for residential low rise, is really what you have in the SB 12. Now, that said, the current SB 12, which is the 2017 version, is about 15 to 20% more efficient than the base NBC 2015 936. So Ontario is already, and has been for 4 or 5 years now, has already been up the ladder. And so when you look at this new tiered energy code that everybody's talking about, the national tiered code, Ontario is already up around tier 2, if not tier 3 in some cases. And the one difference between there is a similarity between SB 12 and 936 in the national code. They both have a prescriptive option and they both have performance, whereas your step code in BC is entirely performance, right?
Right.
But the performance is the one that what we're finding is, well, I'll just be quite frank. As a builder, if you're not doing performance path, you're leaving thousands of dollars on the table with every house.
That was the other takeaway, the non-window takeaway from the SB 12, from the Cracking the Code webinar was that message.
Yeah.
So now the performance tools, the performance modeling you're doing under SB 12, you're using the same tools as the national code or anything different?
Yeah, so SB 12 fundamentally is the same. So in the 936 NBC, it references, I think it's 936.5, talks about you are supposed to use tools that are ASHRAE, 140, and it gives a lot of variations. And of course, programs like Hot 2000 or, the Passive House PHPI calculator is approved to be used for that, can be used under NBC or DOE Energy Plus, all those programs that are out there, Design Studio. In Ontario, SB 12 took a little bit different tact, and it actually doesn't have a 936.5 where it specifies requirements for the modeling. It just simply says you can use Hot 2000, certain version, and you can use some of the other residential programs like RemRate or Passive House. But at the end of the day, what they want you to do is to do a energy comparison. It's not about the rating, it's about the gigajoules. So that's what you use. Our team, we use all of the various softwares. The majority, though, is Hot 2000. I mean, love it or like it. Modeling, I'll tell you right now, energy modeling. I think it was John Straub or one of those guys says, you know what, it's garbage in, garbage out. They're all wrong, but some of them are helpful. So we pick Hot because it's based on Canadian standards. So there you go.
They're all wrong, but some of them are helpful. In other words, they're not telling you the true performance of the home, but they're useful in determining better from worse.
Yeah, none of these tools are doing what we call as operated, right?
Right.
These tools don't know that it's you and I living in the house, and they don't know that I might have 3 flat screens and a couple of gamers and a hot tub in the backyard.
Right. And I just wanted to say that in the sense that, when we say they're all wrong, but some of them are useful, is from it, it kind of makes it sound like they're useless.
That's right. No, I shouldn't.
Right. And we're not trying to say they're useless. I think what you're trying to say, though, is they're not telling us exactly how your home will perform in the real world forever.
Yeah.
But they are useful in comparing A to B. They are useful in taking into account all the energy flows that we can with our technology, right?
Yeah.
So within the limits of our technology to estimate the heat losses, the heat gains, the relative efficiencies of components, the method of construction, with to the best of our understanding, we can determine what is better or worse, and we can determine what's a more cost-effective or efficient way of improving performance.
Yeah, and I will give some kudos to the Hot 2000 engine. The beauty of using that software, love it or hate it, is that, the monitoring we've done on some large scale projects, it's It's pretty close, all things equal. And the
Okay.
beauty is of the HOT 2000 is that the algorithms in that program are based on Canadian standards. So let me give you an example. If you were to pick up a program like a REMRate or Passive House, they're not using what's called the Alberta infiltration model for air leakage. They're using age-old infiltration models. The HERS rating software uses a 35, 40-year-old LBL that thinks that when a house in a cold climate leaks, the cold air comes in all the holes at the same time. And we know that's not true. We know that the cold air comes in at the bottom and it goes out at the top. And that changes loads, it changes profiles. You know, it's got the HOT 2000 does have the same algorithms or references as standards like the CSAF 280. So I'll be really honest, from a legal standpoint, we feel much more secure using HOT, but that's another conversation for another day.
Right. But in other words, basically HOT 2000, whatever we might think about it or have heard about it, you're finding it to be probably the most useful tool for designing homes in Canada.
It's very helpful. And again, you
Okay.
have to understand the building science behind it. And it can get really frustrating some days. Here's an interesting thing. We're in and out of about 8,000 projects a year, our company. And I can tell you that for 75% of the time, the issues that we have with HOT 2000 is that we didn't fundamentally understand the building science that was behind the reasoning. The other 25, yeah, the tool definitely needs some help, and Enercan's got to do something about it. But the other parts that we're just figuring out what's behind it.
Right. So back to SB 12 then. So basically SB 12 is stricter in terms of the performance expectations of a home than 936 of the National Code.
Yeah, it's about 15% to 20% more efficient than what 936 2015 would have.
Right. But there is a performance path already in 936 that anyone could use if they wanted to, right?
That's right.
And I remember hearing years ago a fella in BC named Murray Frank, when they first introduced that path into the code, doing some modeling work on his own as a consultant and saying, you know what, you can save a lot of money. It's cheaper to build under the code using the performance path than the prescriptive path. And his message was, like yours, you're throwing away money if you're using the prescriptive path. But I guess with an energy performance level that is even more strict than 936, that makes you might say the value proposition of the performance path more attractive.
It does. As you go up these tiers closer to our future of net zero ready, net zero, the performance becomes much more important. In fact, even though the proposed tiered energy code that's going to be coming out later this year allows for prescriptive and performance, I would bet money that by the time builders or designers get into tier 3, 4, and 5, that they're going to use the prescriptive just to get a sense, but they're going to use the performance to comply, because that's where they have flexibility. They can address, unintended consequences. They can save money. Here's an interesting fact. Since the 2012 IECC, which is the code in the US, since the 2012 and 2015 IECC, there are now 27 US states who require one version of that up to the 2018 that require things like blower door testing. And almost without fail, the builders are doing performance path in droves in the US as opposed to prescriptive. And I can tell you it's not because they're more concerned about climate change than Canadians.
Right. So this brings us to the topic of value propositions, right?
Yeah.
Often I've heard people say that, there's talk about let's say an Energy Star window today on the U value path would be a triple glazed window.
Yeah.
So I can see that a triple glazed window has real advantages, and but it costs so much more. Like, who's going to pay for it? There's no payback that's going to interest the consumer. There's no government rebates, and the builder just wants the cheapest windows, because that's what I deal with builders every day. Nobody's interested in a better window. So who's ever going to want to buy a more energy efficient window?
Yeah.
And so tell us how that conversation changes with the performance path that you have found at Building Knowledge.
So there's a couple key factors. So I'm going to take us back in time to the 1980s. I'm a kid building houses. Early 1990s, we start to see designs come across our desk, Canada and the US, single detached homes. You might be lucky to have 8% window to wall ratio, right? That was pretty much average. Now, the average window to wall ratio we as evaluators see coming across our desk is 17 to 22%. Average. So I don't think I have to ask anybody anywhere in Canada, do people want more glass or less glass? Yeah, it's more glass. So so now that we have that we have more glass in houses, we now know, and we did a little study back in 2012, 2013, I think it was. We worked with a client. We took a bunch of archetype of homes in Canada. We did some energy modeling, all the climate zones. One of the outcomes of that was showing that because of the high window to wall ratio in homes, and as the codes change, that we were coming up onto a period where a typical single detached home, you could increase the overall efficiency of the enclosure for less cost and add more effective R value by going to a window of 1.2 U value or better than adding R10, 2 inches of foam, whatever you want, to the outside of a 2x6 wall.
Wow.
Like, need we say any more? And then look at the residual impacts. It's not just about increasing the efficiency of the home. We also know that customers don't like condensation on windows. As a builder, we used to know what time of year it was because of 2 phone calls. We knew it was spring because the phone call came in, "Where's my sod?" And we knew it was fall and winter because the phone calls were, "My windows are wet. What's wrong?" And when you put in a better window, you not only make the house better at a lesser cost than doing a number of other things, you also get rid of some service risks. And this point has actually been brought very sharply into focus this last year with COVID. Because as you would know, what's the lowest recommended relative humidity in homes to minimize the distribution and the effectiveness of viruses? ASHRAE's known this for 50 years. The lowest recommended relative humidity rate is what in any home?
You got me. I don't know.
I'm gonna throw out 40.
35 to 40.
Yeah.
In fact, Florence Nightingale, of all the people, did her studies 100 plus years ago showing that when the humidity is a little bit higher in hospitals or in climates, that the virus does not remain airborne that long, and it makes the capturing systems more effective. And here's what's happened. We're being reminded that humidity is important to Canadians. So gone are the days that when we got a call about condensation, that we can in good conscience tell someone, just turn the ventilation on and drop your RH to 20%. That doesn't work anymore. So this is a real concern. And these are things that even the building code hasn't quite got there. So again, I'll go back to this value proposition. We have, I'll give you an example. We have a very large client right now that builds in excess of 800 units a year. And we, like I said, we're in and out of several thousand a year, various builders, but they alone build about 800 units. They are a production builder. And they compete with, some of our other clients, Mattamy Homes and all the rest of them. A couple of years ago, they saw this coming. 6 or 7 years ago, they saw this coming. So they started to look seriously at glass. And they knew their designs were getting a lot more glass, those low slope roofs, the modern design. And, you want to have a connection with the outside. I don't know why you'd want to have that when you're downtown Toronto, but anyways, that's just my opinion. And more glass. And they saw this coming. So we did some analysis for them and we arrived at the very same conclusion. Going to a better glass, 1.2 U value, mid-range solar heat gain. Be careful, look at the solar heat gain. They were able to more than exceed the building code. They were able to pull some of the other things out that didn't matter. Drain water heat recovery. Why do that when you've got a house that maybe has 1 or 2 showers, that's in, and a condensing boiler? That's my opinion, right? Why go to R60 in the attic? Take it back to R50. There is no effect on human comfort whatsoever or return on investment. So put the money where it belongs. And here's the beauty of it. Their customers and sales team loved it. 3 panes is better than 2, right? I mean, we sort of
easier sell, right? Yeah.
Yeah. And now suddenly you can sit next to your big picture window and you're going to be comfortable, and you're not going to have Aunt Em's Afghan over the back shoulders when it's cold outside, right? But that to me was an example of optimization. Yeah.
So this is really, this is the really interesting story that, I really wanted more people in our industry, in the window industry, to hear. We're talking Ontario. We're talking base code. We're talking the smart way, the most cost-effective way to build under the base code. And that involves a high-performance window, a window that would qualify for Energy Star on the U-value path, because you need that 1.2 U-value to make the energy model work, right? So we're talking triple glazing at this point to get that U-value. So this is now, to a builder who understands what you guys do, to a builder that's using building science to make the most cost-effective, most efficiently designed home, is finding that I don't need to add 2 inches of insulation to the whole house. I don't have to add, how much insulation do you add to the attic to get another R10?
I mean, to get another R10, and it's not going to do anything for you, but you're adding another 3 to 4 inches. Because you got to remember, law of diminishing returns. To cut the heat loss in half at R60 means you have to double the insulation, which is R120. So you can go swim in the cellulose or glass in your attic. Right.
Yeah. So in other words, there are much more, expensive ways to do it. But, the window is not only more cost effective, but you can sell a higher value proposition, more comfort.
Yeah.
Right. You don't have to sit 10 feet from your windows in the wintertime.
That's right.
Or wipe condensation off your kitchen windows, half the year. Right. So these are, as you say, it's popular to consumers, clearly, if you explain that to them. Yeah. And overall, it's a smart decision for a builder to make.
Now, I will say, there's another discussion that we have to have as an industry, and it is taking place. And there's a lot of stress in the system because of this, but that's the discussion about solar heat gain. So we're designing right now, we're the principal consultants on a large project that Canadian home builders and EnerCan are supporting. There's 7 project teams across Canada that are building net zero multi-unit residential buildings. And they are to be affordable, replicable, reproducible, and they're modular in nature. And these teams have been at this now for 2 to 3 years. Terry, you would have heard some of the presentations at the Net Zero Summit on this. Yeah. Every single project, without fail, in the charrettes, one of the biggest conversations was between the mechanical people and the energy advisors about solar heat gain. And here's the thing we have to understand. As we move towards tier 5, we are going to see that the largest principal load in a residential home in Canada is no longer going to be the heating load. It's the cooling load. And it is a real concern. Right now in Ontario, I would put money on the table to bet you that in the production world, townhomes, detached, otherwise, that without fail, between Ottawa, Toronto, Southwestern Ontario, that it is the cooling load that is driving the size of the mechanical systems and not the heating load in every single case. The other thing too, to understand how important this is that not only are we becoming a cooling nation, the majority of comfort complaints and concerns from homeowners is swiftly moving from I'm not warm enough to I am too hot. You talk to your warranty programs, they'll tell you this. We have net zero projects and passive projects where we've got people coming back after they lived in these homes and it's cooling issues.
They're too hot in their
Too
energy
hot.
efficient home.
We're cooking them at the end of February.
You know,
And where is this heat coming from?
I'd love to jump in right there. Thanks for the segue, Al. You know, Andy, you talked about window to wall ratios going up and being, you know, they were 15 and now they're 20, 25, 30. You know what we see here? BC has very few areas that are flat. You know, lots of people are building on slopes. The house might have 25% window to wall ratio or 20%, but 80% of that 20% is on the south elevation. You know,
Yeah.
the north elevation has 3%, window to wall ratio. So we're seeing these huge expanses of glass, even though the overall glazing on the building might not be deemed to be outside of what's acceptable, but it's all on one side or all on two sides because of building on slopes or whatever, right? So
Yeah.
the house might be completely comfortable or acceptable on the north and east rooms, but on the south and west rooms, people are roasting and can't keep them cool
Yeah.
because they're freezing out the other areas of the home. So that's what we're seeing as one of the biggest problems with solar heat gain is not so much just the window to wall ratio of the building, but the window to wall ratio of specific elevations. That's a big problem.
Yeah, I can tell you right now that when we work with our clients and we do some mechanical consulting and design, we like to make sure that whoever that engineer is, that we have their calculations and loads. Because I can tell you that even the engineering world and the mechanical world is just now starting to get their heads wrapped around the effect of solar heat gain on equipment. So, you know, here's a story. A couple, this is an existing home, did a renovation in their new home in the Montreal area. And they had a brand new cooling and heating system put in, new furnace, right? Works beautifully. They get windows replaced a couple years later, and he puts a quote out. He wants 4 quotes. He says, give me the quote. And he says to the contractors, give me the most efficient window you have. So he gets 4 different quotes. So he chooses most efficient. And at that time it was zone 3, right? Efficient all the way to Whitehorse. He chooses the window. Windows go in, not a problem. Except all of a sudden he starts to get phone calls from home. He travels. Something's wrong with the air conditioner. We're not sure what's going on. What he had been sold was a window that complied with ER, not U value. So he puts the window in. This window has a solar heat gain coefficient of 0.7. So now the air conditioner has to be 4.5 tons. And it's not working. We see this every single month. And it's not just in warm climates. We saw this in Edmonton. We were having Edmonton has a minus 39 design day temperature. It's cold. It's zone 7A, right? We were doing a design charrette there. We have net zero buildings being built en masse with a client up there and their energy advisor. The heating load in the MERB is around 7,000 BTUs. The cooling load, 12 to 16,000.
Holy man.
The engineer and the window manufacturer said to the client and the contractor, the mechanical contractor, well, you guys don't need to worry about solar heat gain like we're in Edmonton. And I thought the mechanical installer was going to come out of his chair. He said, are you kidding me? He said, we are experiencing huge issues with cooling here, even in Edmonton. And when you start to look around, it was very interesting. We started to look at the solar heat gain coefficient on windows that were being sold even in those areas, 0.6, 0.7. I mean, folks, you got to understand that number, 0.7 means you're going to let 70% of the BTUs hitting that glass into your house. Now, we got to go back in history, right? Like Al, you and I have talked about this, Jeff Baker and us, we've had some round, discussions on this. And again, I can't say this factually, but I do believe that when ER was brought into being in Canada, that there were notes put into the appendix of the National Building Code. And it said two things. It said using ER may not be appropriate for houses or buildings that have over 16 to 17% window to wall ratio. Now, remember, this was 30 plus years ago, right? Because it may result in overheating. The other part was it's not recommended to be used in what kind of buildings? MERBs. And guess what we're building these days?
Mhm.
So, it's not that ER is a bad thing, but the solar heat gain coefficient is a big deal. It's such a big deal that even the new tiered energy code is going to try to deal with it. There is the new proposed 2020 NBC 936 does suggest, and I don't know that this is going to answer it. We don't know really, but it is suggesting that if the proposed house, the cooling load of the proposed house cannot be more than that of the reference house. So Terry, this is something you're going to want to keep your eye on. And this is something that energy advisors and builders and window manufacturers and mechanical folks are going to need to understand, that what that's going to do is you're not just going to be able to go out and throw in a bunch of glass and a high solar heat gain just to get your energy to reduce on your heating side anymore.
That's what they're doing right now.
I know.
We're getting that spec right now, very high, not very high, but high solar heat gains, low U values, going into a building that has 60 to 70% window to wall ratio on the south face.
Wow. I just find it's probably the biggest, I'll just say it's one of the biggest criminal cheats, and we can't blame it. We can't blame it on HOT 2000. People say, well, HOT 2000 loves solar gain. It does, but HOT 2000 doesn't understand the occupant. You as the modeler, you as the builder, you as the designer are the ones that are supposed to understand what's acceptable to the client.
I think part of the challenge is, and what I see is that they're looking at the values that the window supplier is giving them. Let's say a 25.25 solar heat gain, they're giving them for a 4x5 picture window, and then putting 400 square feet of glass, thinking that that's the value. Well, that doesn't work. And we're seeing that as a problem. I mean, we've been seeing it for years on the north shore of Vancouver, West Vancouver, North Vancouver, with these huge glazing facades on single family homes up the mountainside, where you're using, either medium or low solar gain glass, and the people are still cooking.
Yeah. So here's where the benefit is. And this is where, as we move up these tiers, it's going to become more incumbent and more important on the project team to have someone that gets the building science. And this is going to sound like a shameless pitch for a good building science, and not just any energy advisor or any building science engineer, but someone that really understands the building as a system. So here's the interesting part. These MER projects, several of them, and projects we're doing now, if you're careful, you can start to optimize. You can use the solar heat gain, use good U value, but use the solar heat gain and start to look at the effect it has on your cooling loads. Because here's the thing. Most air conditioning systems are forced air, right? And cold air requires more CFM than hot air. So cold air requires a lot of CFM. A ton of cold air requires 200 to 300 plus CFM. A ton of warm air is maybe 120. So what happens is, if you have solar heat gain coefficients on windows that are too high, it's going to force you to have big fans on your air handlers. And if you have big fans, guess what else gets big? Ductwork gets really big. Right. And the beauty is, and that means too, your condenser has to be big, right? Your heat pump has to be, 2.5 to 3.5 to 4 tons all of a sudden. Well, here's the beauty. Those air source heat pumps typically are pretty pricey per ton. After you go over 1.5 tons or 2 tons, you start to be hitting about $800 to $1,200 per half ton as you go up. So why don't we take the tonnage down on the heat pump? Let's take it down by $1,000 or $2,000, a smaller heat pump, and let's put it into the windows. And let's put a better window in with a little lower solar heat gain and comply with U value and not ER.
Yeah, that's a really interesting point. And as a window salesperson, which I'm not, but obviously I talk to a lot of them, it becomes a bit of a tougher sell because generally speaking, a high solar gain window is cheaper than a low solar gain window with a better U value. And it sounds like you're just trying to pitch more cost to the client.
That's right.
When they're being told, no, I want this high solar gain window because I'm going to get all this free heat.
Yeah. And that's where you also have to, then we go to what we call the third dimension and go, okay, what do you want the client to feel like in the home? What do you want to feel like? Do you want a window, number one, that doesn't get condensation? So we can talk about condensation resistance. The other thing too to talk about is thermal comfort. That's a whack of glass. So, now we can use some simple tools like the LBL tool to show whether you're going to be able to sit within a meter of that window on a -5 degree day and actually still be comfortable or not. So that's where sort of that next step goes. And what the other part of it too is we do know as well that you diminish exterior noise as well substantially. The house becomes quieter. And I mean, you can go right down the path, but again, it becomes incumbent on the advisor and on the team to look at the whole impact. So, we look at it that it's a good news story up front because you likely can do some performance alternatives. Performance path is the way to start. You can probably trade some things off. Then look at the impact on mechanicals and the synergies, and then look at the impact on the client and service and warranty and comfort side of it. And generally speaking, by the time you work them through that, you can get them to a pretty good window. I will say the one thing that is, it's a tough thing for window manufacturers, especially for reps. I was at Jim Larson at Cardinal told me once there's something like 60 different low E coating arrangements you can get. Like, how much more confusing can it get, right?
Yeah.
So, but yeah, it's I definitely, our team these days, we have probably almost 400 net zero projects now that we'll have completed by mid this year. I mean, we're very fortunate to work with a really cool bunch of builders, and the EEAs in Canada, the KC associated REAs, they're a great industry, and we're seeing this net zero ready thing really increase. But out of all of that, there is a very common theme that we're seeing is that you've got to use good building science. We don't want to end up, I'll make fun of our engineers and our tower guys for a minute here. We don't want to end up with the same situation we have downtown Toronto right now. We took these glass towers from Zone 4. I think we got the designs from you guys somewhere out west, right? And they complied on performance path. All they did was they modeled glass towers in Zone 5 and took advantage of high solar heat gain. They built these things, and now you know what? Come 1 o'clock in the afternoon, you've got residences that can't even stay in their condo because it's so hot. It becomes so hot, it becomes untenable. And you've got Ted Kessick, professor at U of T, and John Straub, recorded in the paper there a couple of years ago saying this is ludicrous. They said that the issue with this is that because of no building science, because of trying to cheat the system with high solar heat gain, you are building the slums of tomorrow. And the reason they said that is because what's going to happen is the only people that are going to live there in the future are the ones that have no options and have to be subsidized.
So we do have a couple questions online. If you guys don't mind, I can start that.
Sure. Yeah.
Okay, so let's go online. So we had Patrick asking, what are the costs to contractors to get energy modeling / compliance certification done?
Good question, Patrick. It depends on where you are. So I'm going to say on the low-rise residential side, The good news is it depends, right? If you've got a single detached home, let's say a production style home, and you just want to do a comparison with code, and let's say there's no air testing required, because again, that's an option. Just a model, it might be a couple $100 just to show compliance and to do some comparisons. But be careful what you pay for, right? Our team at Building Knowledge, we might charge a little bit more. We might charge, maybe $300 to $500 on just a straight up comparison. We do an optimization to do something like that. If you're doing multifamily, obviously there's economies of scale. So, we're not talking tens of thousands of dollars, and rarely are we talking thousands, unless it's a big custom project, right? So the other part too is we find that, some of these folks are used to, I'm going to say part 3 building costs, and it's very different in the part 9 world. I'll just say as a good KC registered energy advisor, I think most of our members would tell you, if we can't help you do performance meet the performance of the building code through performance for less than prescriptive, we're probably not doing our job.
Okay.
Yeah, I'd like to add to that, if I could, that engaging somebody that does this work, that really knows their stuff and does a good job, is probably some of the best money you'll ever spend.
Yeah.
And potentially you'll gain that money back in your build. How the build ends up being designed, you can potentially come away saving that money because you've saved on a component that you don't need to upgrade because you've done smart upgrades somewhere else.
That's
where
right.
we see it, typically we see an energy advisor recommend 3 different options to a builder for a step code build, let's say for step 3, for example. So the window company will quote 3 different packages of performance.
Yeah.
And, the other trades obviously are doing their thing. And more often than not, we're seeing that the builder is coming back and selecting a more expensive, better performing fenestration design because he can offset it in less insulation in the slab or less mechanical systems or et cetera, et cetera. And oftentimes that money is saved on your final build design. So get a good one and let them do their work and make some smart decisions for you. And it's money well spent.
I love to hear that, Terry. It's a no-brainer when it comes right down to it, for sure.
Awesome. We have Kira mentioning, bravo, I totally agree. We have a lot of issues as homeowners. It is very important to watch the solar heat gain. So here it says it's SHGC, so I don't know what the C would stand for. You probably do, right?
Coefficient.
Solar heat gain. Yeah.
Coefficient. Yeah. Okay. And we have a couple. We have one question on YouTube. So the question starts with it's slightly left field question, but it might be great to hear from your expert opinions. Any thoughts on indoor connectivity as part of window value proposition? Louis glass attenuates wireless signals while the society becomes more and more wireless. I don't see a lot of discussions on this. So this is a little bit out of left field, but
certainly not anything that I'm familiar with as being a problem. I'm not totally wired in my place, but certainly any of my Wi-Fi signals and things like that are I can be outside and still capture my Wi-Fi and that. So I'm not sure that other components might be having problems with that. Maybe, I don't know.
Yeah, maybe
that's
cell phones. Maybe that's what they mean too.
Yeah, that's interesting. That's the first I've heard of that. I mean, we live in my family and I have 4 kids and my wife, we live in a net zero ready home, have for 6 years. We have triples for the first time with a mid-range solar heat gain. Love it. It's the most comfortable home we've ever lived in. Nobody paid me to say that, by the way. And we've got a bunch of techie kids and we don't experience an issue, but it is interesting. On that note, we are seeing things like, these new window technologies. So some of these variable solar heat gain windows where you can change the solar heat gain. We have a project that we've worked on in London, Ontario at a project called West 5. It's Canada's first full net zero site, 70 acres. It's almost half done. It's by Sifton Properties, and their office building actually uses the low volt system that can dim the windows, and it's connected with the mechanical systems. And man, is that cool!
I actually worked with a company out of Denver, Colorado, a number of years ago, looking at what they were doing, and they had actually created a system where that inside light of glass was heated. That was really cool.
Interesting.
Unfortunately, we couldn't come together on a plan to work together, but I was in this guy's office in Denver in the middle of winter, a few feet of snow outside, and sitting beside a window that was probably 30 square feet, and I was right beside it, and it was warm to the touch. It was quite incredible.
Yeah.
So who knows what's coming? Who knows what's coming?
One of the other things too, Al, if you don't mind me, I do want to bring up this topic of Surface 4 Low E. It's
I was thinking of it, but go right ahead. Yeah.
So from a building science standpoint, a practitioner, I really have concerns with this. And, I'm still reading the research, a lot of the stuff that was done coming out of University of Waterloo. There's been stuff that's been done in the past on the Surface 4 Low E. I used it in North Carolina. I mean, I-89's been around a long time. Sorry, I called out a manufacturer spec, but it's been around a long time. This is nothing new. But I can tell you what, the thing that concerned me the first time was when I saw Surface 4 Low E in a Zone 6 house, and the condensation was across the entire face of the glass, and the interior relative humidity was at 32%, and it was minus 15 outside. And as a builder, that bothers me. I had a conversation not long ago. We have a client that, was told, well, we can now get double pane windows that have really good U values. They're getting close to 1.2. Actually, they're about 1.4 in most cases. But it's got this third coating, and it makes the person feel warmer, and it costs less. And I'm like, oh yeah, I've seen that glass before. And then it dawned on me, wait a minute, where are you building? Well, we're going to be building in Edmonton. Hold on. So I sent him the picture. And this is really scary to me because, the products you buy at Home Depot could care less about where you live. That's your problem. They could care less if you buy it and go install it in Whitehorse or in Fort Lauderdale. And I think that we have a responsibility in the industry, those of us that know, and as manufacturers and building science people and engineers, that when we know there's an unintended consequence that could affect the consumer like that, that's a big deal. So yeah, we've got clients that are bringing that to us, and I still, even though there's better spacers that insulate the edge of the glass, and it bothers me that some manufacturers won't even give the client, when they ask, the condensation resistant factor. In fact, the last answer I get from a manufacturer is trying to sell Low E, Surface 4 Low E was, well, we don't have that number. It cost us tens of thousands of dollars to get. So I flat out said to him, tell me why you don't have it. And it was a bit of a sheepish response.
I think that we would.
And by the way, it doesn't cost $10,000 to get the answer.
No, it certainly doesn't.
You can get it for free. So
I think we would all like to see a really reliable study on that. The city of Vancouver, obviously with their thermal performance requirements, fourth surface Low E is very popular there.
Yeah.
We've sold thousands and thousands of square feet of it. And I can't recall a single complaint about condensation. Now it's Vancouver.
It's
right?
Zone 4. That's the same. That's the same
right.
climate zone as Knoxville, Tennessee. I mean, seriously.
So there is obviously some appropriateness of that product, but we'd love to see a study. Like I've looked, and there's nothing reliable as far as a study on that effect.
Yeah,
but I agree.
Well,
there's challenges there.
Yeah, let's do that. I mean, and there's a lot of products like there in building technologies that you don't use in Edmonton that you might use in, Toronto, and vice versa you wouldn't. And that's okay. It's just be really careful, because we're putting people in these homes. And honestly, the last thing I want, here's the thing you have to understand about builders. A mistake on a custom home is one thing. A mistake on 1,000 homes is a class action.
Mhm.
And at the same time that we're telling homeowners that they should be keeping relative humidity a little bit higher for health reasons that we've known about for over 80 years, and we have concerns with condensation on windows, now we're going to put in a glass that has a really low condensation resistance factor. That's an issue. So again, I think it's just let's be honest with each other. Let's take our time. I do find it interesting that 8 years ago, we saw some window manufacturers. As a builder, I used to price all you folks out all the time. And pricing was all over the map with tri-pane. Some was, 55%, others was 30%. And it's the same way today. And what I find interesting is that the cost for a good window, 1.2 U value with the ability to moderate your solar heat gain appropriately, the best costs actually are coming from the manufacturers who invested in the frame technology and in their product line so they could do it not as a custom order. Right. But they started it 8 years ago.
Mm-hmm.
So we do have a couple more questions if you guys don't mind. I have Joe Kelly asking, is VIG tech becoming any more popular and or cheaper?
Vacuum insulated glass. Mm-hmm. R10 glass. Where are we, Terry?
Well, I mean, nobody's doing it around us right now. And I try to keep an eye on whether or not we're going to see any of that. It's going to be really interesting if it does arrive, because all of these manufacturers that have fabricated these large, deep frames to accommodate triples are now going to be dealing with sealed units that are 1/4 of an inch thick or so. A complete design change to products could come along with that, but I haven't seen any in our market yet, so we'll see. I don't know.
Terry, can I ask you a question? I've heard that and read some studies that part of the issue with the VIGs is the fact that because of that, the pressure of the seal, that it requires almost like a metallic sealant, and so you get incredibly high thermal conductivity at the frame. So it seems like the challenge is the frame. We had the reason I say this was I had a client that was going to be sold out of the U.S. So we'll say it was U.S. Out of the U.S. was going to be sold a VIG, and they were given center of glass U values. And they had another manufacturer that was selling to them, but that other manufacturer was honest and forthcoming enough to say, hey, we can give you the same thing, but understand that the frame, because of the metallic makeup of the seal, it has incredibly high conduction at the frame. And they were actually honest enough to say to the client, our standard triples with a 1.1 or better have a similar overall performance as our VIGs at this point in time. They said in the future, we hope that our frame insulation technology can get better, but at this time, our good triples are basically as good as a whole. That's sort of interesting.
Yeah.
Yeah, so that is one of the issues with the vacuum insulating glass, is that you get a lot of conductivity at the edge. And to mitigate that, it's desirable to bury that edge deeper into the window frame. But today's window frames may not have a glazing pocket deep enough to mitigate that effect. And so a single double glazed VIG panel is really not an answer to anybody's thermal problems north of the US border. What you do see as a more viable product is to make a sealed unit between a VIG and a regular pane. Now you can put the VIG on the inside of the window, have the single pane on the out, the regular glass on the outside, and now you're sort of mitigating the effect of that spacer effect, and you're getting the benefit of putting the VIG behind a layer of gas and external, and maybe an outer pane of glass with a lily coating on it. So, but now you're getting into very high costs, and at this point, it just isn't cost effective to manufacture VIG at crazy sizes like a residential window order, where every window's got a different size of glass, right? And there's probably no more than 2 or 3 panes alike in the whole project. So it's just, that industry isn't even making high volume production yet, right? And by the time that becomes high volume to the residential industry at sizes that builders need, we're still probably 5 to 10 years out, and it's not even clear yet if that'll be viable or if there will be more cost-effective ways of getting to where we're going. Given that realistically, we know that with a well-designed window frame, a regular triple pane unit with 2 low E coatings gets you down to passive house level and better.
Yeah.
That's it, and it's not that expensive, right? Now you're going to have to be less expensive than that triple glazed unit.
Yeah.
And so it's not clear yet. I mean, if you had a glazing product that dramatically reduced the U value, way better than our best glass.
Yeah.
But we're not there yet. So
I stumbled across a company, it's a Canadian company actually, a couple of days ago. I haven't done a whole lot of research on it, but you might want to check out Light Zone, LITE, zone.ca. It kind of looks like something along the lines of Heat Mirror, but it's not. They're touting amazing U-value performance of the glass.
Interesting.
So, yeah, I don't know much about it, but it looks pretty interesting in the numbers that they're touting. So, lightzone.ca, check it out. It might be something that's coming our way.
So we have, just so you know, we have Patrick saying that they will be at Top Glass, the trade show in Toronto. Well, not going to be in Toronto this year, but
yeah,
April 21st. He manages to plug his stuff even when he's not.
I was seeing dual glazed units with 3 and 4 layers of these films inside of them that had incredible U values. So who knows? Might be something interesting.
I will say one thing. If I could say anything to the window manufacturer, there's 3 things that come to mind. As a builder, working with builders, here's 3 things I would say. Glass isn't going away. In fact, it's only going to get bigger. So it's just the way it is. The whole idea that, for instance, the National Architectural Associations are developing a biophilia architecture language now, and our connection with the outdoors, we're going to have lots of glass. Number 2, codes don't drive change. Consumers do. And we always have to remember that. When it gets bad enough for long enough with the consumers, it'll change. So we are seeing homeowner expectations go through the roof. Ask any group of builder and building officials what changes faster, codes and programs or homeowner expectations. You know what they're going to tell you? Homeowner expectations. They're going through the roof. So that's going to do it. The other thing too, I would beg and plead with the window industry, work with the construction industry, principally the Part 9, on water management. Let's step aside from the glass for a minute. Let's step aside from the frame technologies and the low E coatings, and let's talk principally about the fact that we are about to embark on putting more insulation in homes across Canada and making them more airtight. And we can blame each other. Well, the residential industry doesn't water manage like they should. The residential builders are going to come right back and say, I'm buying windows from all of you right now, and not a single one of you have ever said anything about the A440. And right now, our opinion at Building Knowledge is we've got to work together, or we are going to have, I hate to say this, we already have a crisis of huge magnitude on our hands when it comes to water infiltration around window and door penetrations. If you want a hint of that, look at the class action lawsuit in the state of Pennsylvania.
The conversations around that topic right now are fast and furious. I mean, there's so many people talking about it. But, the way your comment that you just phrased was really interesting for me. There's a lot of problems going on right now with water penetration around fenestration. It's not coming through the fenestration.
That's right.
That's really, really clear thing you need to understand.
Right. Yeah.
And I think that from a manufacturer's perspective, of course, we want to make sure that those challenges are minimized. But we build windows, we build doors. We're not building science professionals. We're not envelope professionals. And to look towards a window supplier for your envelope details or your,
it's tough.
That becomes a really, really convoluted, challenging discussion on who's responsible for what. And like I say, the conversation's going on right now. I mean, about it.
Here's where, I mean, there is a massive business opportunity here, folks. Let me throw this out there. Someone's going to win this game and they're going to get it right. And the largest builder in Canada is going to take you up on it. You go out there and partner with Zipwall, DuPont, Tyvek. Go partner with them. Work together. One takes care of the other problem. You've got Tyvek out there that says, we'll give a 10-year watertight guarantee if you use our products. That is a blessing in disguise to both you and the builders. But again, we need to help our building industry. And again, I'm not blaming Windows at all. I mean, we all know that Windows, I mean, what's the maximum life warranty on a window for performance?
On our website, I don't know. You'd have to look it up.
Okay, so
well, some people are offering 20 years. Others are giving it lifetime to the original owner.
There you go.
The original customer, right?
So that's nice. Here's the thing. The assumption is at the national level, the building codes is that a residential home lasts for 50 years. And from a building science perspective, I would say, let's all acknowledge the fact that windows and doors, they're meant to be upgraded and replaced sometime in 50 years. Let's just get over it, and that's okay. There's nothing wrong with that. However, that means it's incumbent on the designer, the architect, and the builder to design the openings so it can happen that way. John Straub, he did a great presentation a couple years ago. He said the day's going to come, and it's going to come really fast, because he said we can't put any more insulation in walls, and we can't make houses any more airtight till we get this figured out, because they have less drying potential. But he said the day's going to come where we're going to have to install these things so they can be swapped in and out easily.
Yeah, you see that here. The window industry, certainly Fenestration Canada, wants to be involved in that conversation, no question about it. I think the solution is that we accept the fact that window installers are not the nephew of the cousin of the brother of the builder.
Right.
They need to be somebody that's trained. They need to have good understanding and good science behind what it is that they're doing. We all agree that needs to happen. Pulling that together, it's a little more challenging, right? But it's certainly, it's certainly a task that Fenestration Canada is participating in, no doubt about it.
I do want to give you guys kudos for the efforts. I know right now you're engaged with the Canadian home builders and others, sort of looking at what that looks like. Some criteria. I love it. Mm-hmm. And I guess what I'm saying is I just want to reiterate the fact that this is a huge issue. We all know it, but keep in mind that it's going to become situation critical. It already is, but it becomes even more of an issue as we move up these tiers. We have a saying, and we say it tongue in cheek to clients and others, is if you can't get your windows flashed right, don't even think about net zero. Just don't.
I'll tell you, here's my view of the solution, and I hate to promote any kind of regulation because I think we're all regulated to death.
Yeah.
Make window installers a required training requirement under code or regulation, because now you create a pull for somebody to develop good programs.
Interesting.
To develop installation programs is not cheap, especially nationally with all the different regional aspects that come into play. It's a huge monumental task. I've been talking to people about it for over 30 years. Yeah. Nobody will do it. I shouldn't say nobody, that's not fair. But there's little uptake because until you have client for your product, you're not going to invest thousands and thousands of dollars to build that product. So make it a requirement that fenestration installation is a trade that needs to be, regulated in building. And then it'll change like that. It'll change overnight.
Yeah.
So guys, we'll need to wrap this up soon, but we have a couple questions left, so I'll go to those. So we have Steve asking, are the builders in Ontario looking at the performance requirements and if the window have been tested in accordance to NAFs in addition to the energy values? Do you guys know that?
I would say yes. I mean, in the part 9, in its most simplistic, I would say yeah, and they're very conscious of that.
That's the extent of what
Gary?
What you guess?
I don't know.
Don't know.
Yeah.
Okay, something to check. he also adds like water management, yes. So I guess he, he agrees with
Everybody
you guys.
agrees, yeah.
And one last question here that we have from Patrick. Would like to know Andy's opinion on rain screen concept for window installation.
Oh. Well, I do think that BC has it right. And, you know, let's be honest, the reason they have it right is because they've learned what not to do. So the rain screen concept, obviously right now, a rain screen is only required in certain areas of Canada, depending on the moisture index. So that's all under the building code. So most of, you know, Vancouver, all those areas, you're going to fall under rain screen territory. From a building science perspective, good water resistant barrier, second plane of protection, good rain screen, absolutely. And we would like to see, and I think, you know, folks like RDH and others would agree that when you are looking at climates where you have such high water loading, rain screens are definitely needed. And not only that, you need to be very particular about where the rain screen and your water resistant barrier tie into the window and door. You know, for instance, is it on top of the exterior layers of insulation or is it below? I mean, there's some building science things there. So I think it is important. I think rain screens are important. I would also suggest that there's probably some areas in Canada where rain screens would very much help, even though it's not identified under the moisture index of the National Building Code as needing one. But honestly, I'd just be happy to see subsil flashing under every patio door in Canada.
Okay. So Al, did you have anything else to add to wrap up the show here?
Well, I would say my final comment is, Andy, I'll be talking to you about installation.
Yes.
We'll take you up on that. Okay,
Yeah,
we're gonna talk. Okay.
Yeah.
Thank you very much for being on the show today, Terry. Thank you very much as well.
Thanks. Al.
Honestly, this is, I think, one of the most interesting Tech Talk shows we've had, and I really appreciate the practical, experience-based, findings that you've presented to us today. I mean, it's, that it's grounded in building science, that it's makes sense to builders, and I guess the high volume builders who are dealing with the highest risk, like you say, who don't want a class action, are the ones maybe who are most attentive to these things. But I think everyone can benefit from what they've learned and why they do what they do. Yeah. So I think it's just fascinating, and it's so helpful, I think, for our industry, the window and door manufacturers and suppliers, to understand this changing value proposition, and it's something that's evolving across the country. It's not uniform everywhere, but I think it's helpful to understand that there are places where the value proposition has changed, and there are places where it will change. And for people to understand that, I think it might put a new lens on future product development plans. I'm hoping that Fenestration Canada members that hear this show are going to think maybe a little bit differently about the priority of their product development plans, about if we're going to refresh a product line that's 12 years old and we want to update it for all kinds of reasons, maybe production, maybe warranty, whatever, maybe it's worth also seeing what's the best thermal performance we can get. Maybe can it accommodate triples? You know what I mean? So that when there's a demand for triples, our product will be ready for it, right? Can we make the frame as energy efficient as it'll be, so it'll be relevant 10 years from now, and not just be, made irrelevant because everybody wants something at 1.0 and my 1.2 is now sucks, right? So I think it's helpful, really, for this kind of conversation to help our industry appreciate the changing landscape with respect to why builders are making the choices they're making. And honestly, I hope that it'll help to drive, productive, profitable innovation in our industry to actually supply the products that are going to meet these needs, and develop those products here in Canada. So thank you very much for being a guest on Tech Talks. Thank you, Terry, for your role. And we look forward to chatting with all the rest of you again next month.
Thanks.
Thank you, Al.
Thanks, everyone. Bye-bye.
Good seeing you, Andy.
You are a member and want to be part of the live recording of Tech Talks? Easy. Visit fenestrationcanada.ca and sign up for the next show.